So year 12, today we are looking at the very last topic, which is Unit 4, Topic 5. So over here, so we've looked at Topic 3, Discrete Random Variables, Topic 4, Continuous Random Variables, and then Normal Distribution, and then Topic 5, Interval Estimates for Proportion. So our last topic that we are looking at. Here's our formula sheet. We've done binomial theorem. We spoke about a bit. We've done it in year 10. There's your binomial probability. And over here, if you have binomial data, this is how you calculate the mean, and that's how you calculate the variance. And remember, standard deviation is the square root of variance. Then going back to Unit 2, looking at discrete random variables, that's how we calculate the mean and the variance. And then, of course, when we move on to our normal distribution, looking at continuous data, we work with the integrals of functions, calculate the areas under the graph to find the mean and the variance. We've looked at sample proportion, where the mean is p, and that's how you calculate the standard deviation. The bottom three, we did a bit of that in year 10. Conditional probability, we looked at quite a bit. And you can see the only thing that we haven't done yet is this over here, which is called the approximate confidence interval for P. And this is what we are going to look at today. Before we start, just a reminder of the difference between P and P hat. So P, remember, is the population proportion, and P hat is the sample proportion. And for both of these, we've got this little formula to calculate it. So the number of data values divided by the size of the proportion or population. And here X is the, remember when you went into the high school and you asked who's got blue eyes? So that was our sample proportion. You went to the primary school and you asked a certain number of students, and we got the result for that, which I can't remember. But so just for difference between these two, that's pretty important. And just a reminder as well, remember P is not population, right? It's not population. P is a proportion. It's a fraction, and it looks like that. It's not just a population. So remember, that was a bit of an issue last term. Okay, so let's have a look. So we're on page 71, and as you can see, it says Unit 4, Topic 5, Confidence Intervals for Proportions. So this will involve a bit of reading. So I need you to follow, please, and don't lose concentration. All right, so if you can stay with me, that will be fantastic. So it starts talking about point estimates and interval estimates. So remember, we said that it's impossible to survey the whole population. So what you do is you do a survey of a proportion of the population, which is our sample proportion. So it gives some indication of the value of the population proportion, and that we can use that if we have no other information. So it's called a point estimate of P, because we only have this one piece of data, so it's a point estimate. So for example, if we select a random sample of 20 Australian primary school children and find that the proportion who use social media is 0.7, then the value P hat of 0.7 serves as an estimate of the unknown population proportion P. But having one single point is pretty inaccurate. So it says here, to use a single value to estimate P can be rather risky. What is required is an interval that we are reasonably sure that contains a parameter value P. And we're now going to look at how to build that interval, and that's what we call a confidence interval. So I'll just read this whole sentence here. An interval estimate for the population proportion P is called a confidence interval for P. All right, so you know from previous work that the mean of the population is given by P, and this is how we calculate the standard deviation. All right, then it says, by standardizing, we can say that the distribution of the random variable is this. So by standardizing, remember what comes to mind? What comes to mind are z-scores. So I'm going to write in the formula for z-score. That's a formula for z-score. Then I'm going to use the above values now. So our x, remember, is our sample proportion. So always remember this little diagram that we looked at. Hey, so if we get a lot of samples and the size of the sample is quite large, and we plot all of these sample proportions, remember what do we get? We say that it approximates a normal distribution. And our mean, our middle value there, our middle value of the sample proportions will be our population proportion. All right, so our x values then on here is our sample proportions. Our mean is P from our definition. And then our standard deviation, so I'm going to substitute it in with that. All right, so that's my z-score. This is what you see over here. This is what they're talking about. We're standardizing the score, so it looks like that. So we can substitute these p hats with this. So this is standardizing those scores. All right, now we go back to this interval notation that we saw previously as well. We know that the probability of finding a z-score between negative 1.96 and 1.96 is 95%. So we can substitute the z then by our newly established z-score for population proportions. And now we're just going to do a little bit of algebra, and we're going to multiply both sides by the square root. So we multiply by the square root here, and we multiply by the square root here, and that brings you to this expression here. And then we're going to do a little bit more algebra, and we are going to take the p hats. Whoops, that didn't work. We're taking the p hat to both sides, so move it across, and then we're left with a negative p. And then with a negative p, we're going to multiply through this whole inequality by -1. And remember, if we multiply through by -1, the inequalities switch. All right, so you can look at that, play around, and you'll see that you end up with the following expression. So this is what is called now the confidence interval. So the probability that we'll find that population proportion between these two values over here is 95%. And this is what you see on the formula sheet then. So just have a good look at the way it's written down here. We can abbreviate it and write it down like that. So we just take the brackets down. All right, and we say that then an approximate 95% confidence interval for P is given by this expression over here. So remember, P is my population proportion. That's my unknown that I don't have. P hat is my sample proportion, and N is the size of the sample from which the P hat was calculated. So this is my confidence interval. And then we're going to generalize it, and we can use it for any percentage confidence interval. So instead of having the 1.96 and the 1.96 there, we just replace that by a z-score. And then we can choose whether we want 95% or 99 or 90% confidence interval. So that's, you do not need to know the derivation of it. It's just interesting to see how we get to that. And we did that by standardizing the sample proportions, and that ended up with that confidence interval over there. So we are now going to move on to calculations. So just a reminder here as well. So remember, for 95% interval, the z-score is 1.96. If it's a 99% interval, then you'll substitute the 2.58 in. If it's a 1.6 for a 90% interval, then you'll substitute the 1.64 in it. Right, so moving on to page 74.